Hi, in this video, I'll be describing the task and the associated results of SemEval 22 Task 2, Multilingual Idiomaticity Detection and Sentence Embedding. These were the people involved in organizing the task. Let me start with the motivation for a shared task on idioms. Essentially, state-of-the-art NLP systems, in particular pre-trained language models, are extraordinary in what they're capable of doing in terms of downstream task performance. However, it's been shown that they cannot effectively represent idiomatic multi-word expressions. This is particularly difficult to do because pre-trained language models use compositionality as a central way of stitching together words, and not just words, subwords, to generate sentence representations. As such, it is crucial that we find ways of representing multi-word expressions which are idiomatic and thus not compositional. As such, we propose a task with two subtasks. The first subtask is the identification of idiomaticity. Here, participants are provided with a sentence that contains a potentially idiomatic expression, and they are required to label it as either idiomatic or non-idiomatic. As such, it is a binary classification task. We present this task in two settings. One, the zero-shot setting, and the other, the one-shot setting. Subtask B is a novel task, and it requires models to output the correct semantic text similarity scores between pairs of sentences depending on whether the sentence contains an idiomatic expression or not. And we present this in a pre-train only setting and a fine-tune included setting. The fine-tune included setting allows participants to use training data that is labeled with idiomatic information, whereas the pre-train only setting restricts participants to using unlabeled data, or at least data not explicitly labeled with idiomaticity. Here's the data associated with subtask A. It consists of three sentences: the central sentence, the target sentence, containing the multi-word expression, in this case, gold mine. While the dataset itself provides a fine-grained classification based on the paraphrases, we use a more coarse-grained yes idiomatic, no idiomatic label for this task. Like I said, this data, the training data associated with this, is taken from the dataset Stitch in Language Models. Subtask B, the novel task based on semantic text similarity that I spoke of, consists or requires models to output a semantic text similarity score between two sentences. Consider the second row here, where the multi-word expression big picture is being used in the idiomatic sense. Now, the correct replacement of this using paraphrases would be in the second column, which is to replace big picture with the paraphrase whole situation. However, we can also replace it with the other literal interpretation, which is the large picture. Notice here that the semantic text similarity between column 1 and column 2 must always be 1 because they mean the same thing. Interestingly enough, the semantic similarity between column 2 and column 3 should be the same as that between column 1 and column 3 because column 1 and column 2 mean the same thing. We use this to test models' ability to capture idiomatic meanings because we know that models are very good at outputting semantic text similarity scores when sentences are compositional. Prior work found that models in general struggle in the zero-shot setting, and that therefore this ability to generalize to new idioms that have previously not been seen is the most interesting. Representation of idiomatic expressions without annotated data is yet another problem. Like I said, to this end, this task is proposed in 3 languages, English, Portuguese, and Galician, and across 2 settings, 0 shot and 1 shot, and parallelly in subtask B in the pre-train only and the fine-tune included settings. In terms of participation, we had an incredible number of participants participating, with close to 100 registered participants who organized themselves into 25 teams. We had 650 and 150 submissions in the practice and evaluation phases respectively. We've also had 16 of these teams who've submitted papers. Here's a chart that presents a quick overview of the models that were used. In blue are the models that are using transformers, and in red are the alternate models. As you can see, most participants use transformer-based models, with XLM Roberta being the most popular. Here in this chart, we present methods that were used by more than one team. As you can see, data augmentation and manipulation of the loss function seem to be most popular. This was followed by adversarial training, ensemble models, and different masking strategies. Overall, in terms of findings, we find that models that perform well on the 0-shot setting, this is for subtask A, which is identification, do not perform as well on the 1-shot setting. And those that perform well on the 1-shot setting fail to perform well on the 0-shot setting. This is rather interesting, but it is intuitively clear, because what is required in the 1-shot setting is recall, because we already understand what that idiom is, or we have some information pertaining to what that information is, and we need to then identify the same usage. Whereas in the 0-shot setting, we need generalizability, and this reflects in the methods that were used. For example, methods that perform well in the 0-shot setting used adversarial training and so on, and those that performed well on the 1-shot setting used more powerful PLMs. In terms of subtask B, which involved the representation of idiomaticity, a lot of teams focused on improving semantic text similarity, as that is the metric that we use. In general, these methods performed better again in the fine-tune setting, where some data is provided. In the pre-train only setting, which requires generalization, the explicit representation of idioms seemed to have helped quite significantly. So the trend seems to be consistent. In both identification and representation, there seems to be different requirements based on whether we've seen an idiom before, or if we need to identify an idiom that we have previously not seen before. In terms of future work, so the trend seems to be clear. There seem to be significantly different methods required when we have seen a particular idiom before and when we haven't seen an idiom before, both in terms of identification and representation. And there seems to be a significant gap, especially in the representation of idiomatic expressions. We hope that our findings will generate interest in finding efficient ways of representing idioms and of detecting idioms in this 0-shot setting. We present both the task and our findings in a lot more detail in the paper. The task remains active on CodaLab, so you can go to the site. From there, you can see all the other papers that were presented as part of this task, and you can also participate in this task. Thank you very much for listening.